Saudi Arabia, the holiest site for Muslims, is surrounded by Jordan and Iraq in the north, the Persian Gulf in the east, Yemen and Oman in the south, and the Red Sea in the west. Though the land is in between two water bodies, the land is dry as the Sahara Desert. To be accurate, 95% of its area is covered under sand. It is the only country in the world where not a single river passes through. The annual rainfall of the region is below 95 millimeters. Welcome back to Cosmos Observer, where nothing goes unobserved in the universe. The land was not always like this, though. It saw a significant increase in rainfall around 10,000 years ago and an expansion of lakes and vegetation, which helped human settlement across the peninsula. Unfortunately, a series of droughts in the millennia changed the whole ecosystem of the region. Now, the land is all covered by sand and sand dunes. Sand has coarse grains of rock and has very poor water-retaining capacity. Listening to this, can one imagine the presence of lush green vegetation over there? It is hard to digest, but surprisingly, the land has a few pockets where agricultural production is carried out with the help of an irrigation system. Irrigation is an artificial method of supplying water to crops under controlled pressure and frequency. Primary producers can cultivate a variety of crops that are abnormal to the natural habitation. Just to name a few techniques: drip irrigation, sprinkler irrigation, and center pivot irrigation system. The principle of all these irrigation systems is per drop more crop. Although there is scarcity of water on the surface of the land, the region is lying on water reservoirs known as aquifers. From there, Saudi Arabia has been pumping out water for years. A good portion of that pumped out water goes into the agricultural sector. Currently, the nation has 35,000 square kilometers of land under cultivation, more than 3 times the size of Qatar. Compare this to the early 60s time, it had only 400 square kilometers of land under agriculture. On one hand, the whole world is drying out from the impact of climate change, while on the other hand, Saudi Arabia is turning from a desert country to a green nation. How does it manage to reverse this? As stated earlier, the kingdom has only one source of water, which is underground water, but it may soon dry up if Saudi Arabia continues to increase its agricultural land. To conserve its water resource and be agriculturally independent, the nation has adopted a center pivot irrigation system to irrigate its farmlands. It was invented by a farmer named Frank ZYBACH in 1948. The center pivot irrigation system is one type of sprinkler irrigation that involves a mechanized irrigation system. It has a single major pipe that rotates in the air and is supported by sprinkling towers. The pipe itself consists of equally spaced nozzles to supply water to the crops planted on the ground. While the pipe rotates, water is released uniformly from the nozzles to the plants. All the nozzles of the pipe and of the towers have the same flow rate. This ensures uniformity of water. Any part of the land neither goes dry nor does it suffer from excess water. The system can be customized as per the owner's land area, but the maximum it can cover is 130 acres in a straight system and closely 155 acres in a swing arm system. This makes the system quite suitable for large-scale irrigation, especially where the water is scarce. The center pivot irrigation system is designed in such a way that the sprinklers located near the pivot cover a small area when compared to the nozzles located at the end of the pivot. The main component is the pivot point on which the whole mechanism revolves. This is the area from where water first enters. The second important component of the system is the control panel. As the name indicates, the operator of the system can start and stop the machinery and change the direction and modes of operation, like running dry and running wet. Presently, numerous types of control panels are available in the market, ranging from basic to advanced level. The farmers can choose considering their budget and requirement. The third component is the drive tower or drive unit. It touches the ground and contains hardware that allows for the movement of the system. It consists of wheels, a base beam, a drivetrain, and other things that help the machinery move. The fourth component is the drive box, which further controls the drive tower. This makes the whole machinery move in the right direction and for a specific period of time. As the machinery can be controlled by a single person, it significantly reduces the cost of production. With this system, there is no need to hire labor to irrigate the land. Along with it, it saves time. A large area can be covered in just a couple of minutes. Compare it with the bucket irrigation system, where farmers supply water to their crops in a bucket. Irrigation on a massive scale by traditional methods is not practically possible. Hence, the center pivot system saves cost, time, and water. Unlike the furrow irrigation system, the center pivot system prevents soil and water erosion. When the field is submerged in water, it will obviously suffer from water runoff, and the topmost fertile soil will be washed away. This is where the center pivot comes into picture as a savior. By preventing runoff, it reduces the water bills of the farmers. Different crops require different amounts of water. Like kharif crops, which are grown in the monsoon season, are usually water-loving crops. They need immense quantities of water. For example, rice, while the rabi crops, which are grown during wintertime, demand less water. By controlling the frequency and amount of water, this problem can be half sorted out, leaving the temperature and photoperiod requirement in the hands of nature. The center pivot system is 80% efficient compared to other traditional modes of irrigation like canal irrigation system, basin irrigation system, etc. The old systems could only supply water, but this system is also good at fertigation. Fertigation is a mixture of supplying water and fertilizers to the crops simultaneously. Apart from fertilizers, the system can also sprinkle pesticides, weedicides, and other nutrients required either for the plant's growth or for enriching the soil. This protects farmers from direct contact with pesticides, herbicides, virucides, etc., which are extremely harmful to humans. The farmers suffer from depression, Alzheimer's, lung infection, etc. Since the system beats all other irrigation systems in almost every aspect, 2/3 of the land is irrigated by this method in Saudi Arabia. The Saudi government is also supporting farmers to adopt this technology. They are providing incentives to primary producers to irrigate their crops by this method. In the beginning, the farmers were not happy with this new system. They used to complain about the corrosion in the pipes. Later, high-cost steel pipes with polyethylene pipes were used that do not corrode. Depending upon the salinity of water, the replacement of pipes occurs after every 3 to 5 years. Though the system saves labor costs, it has a high maintenance cost. Apart from this, a skilled person is required to operate the system. The other disadvantage includes the shape of the land. The system works only on a big circular patch of land. Hence, not all big farmers with square-shaped land can adopt it. The non-renewable underwater ground supplied 92% of irrigation water in Saudi in 1992. Indeed, 92% is not a small percentage, and this is what might have persuaded the country to switch to something sustainable. Although the center pivot system follows an efficient water use principle, it doesn't solve the problem, considering the rate at which Saudi Arabia is turning its sand desert into green farms. The system can only slow down the rate of depleting underground water. This intensive agriculture practice is making life more challenging for the natives. The natural fertile land is turning into desert, and the natural pastures of palm trees are also dying due to the absence of underground water. The wells have to be dug deeper to reach water, and the annual scanty rainfall won't be able to bring any change in the current situation. When the Saudi government felt that the situation was getting out of hand, they called Stanford University permaculturalist Neil Spackman and Harvard University bioethicist Mona Hamdi. Spackman lived in Saudi from 2010 to 2018. He checked dams and other things, which helped in the rainwater harvesting. Both Spackman and Hamdi used ancient methods to conserve seasonal floods and train the water to flow in useful streams. In addition to this, a project was started in which drought-resistant trees were planted to maintain the greenery and cooling effect in the region without letting the groundwater table go down. Everything comes with a price. Though the sandy desert is turning green, its water level is going down. The government needs to make a choice between vegetation and the dignified survival of its population.